Okay, everybody, welcome to Physical Science today. We are going to talk about section 2 in our chapter, and it is also what you need to know to do the second part of that worksheet that will be due tomorrow. Okay, so section 2, characteristics of atoms. Okay, characteristics, so atomic number. Okay, and that's the number of protons in an atom, and it's kind of like the name. It's another name for an atom because, or it's an identifier for an atom. Every type of atom, which would be an element, will have a distinct atomic number. So, magnesium's atomic number is always 12. And that means that there's 12 protons in every magnesium atom. You can never, if you had 13 protons, you know what you have? Aluminum. How about 46 protons? Palladium. Right? So let's take a little closer look at that. See this right here? The atomic number, if you look at your key down here in the bottom left, this blue number in the top left of each corner, those are the atomic numbers. Okay, so 5 is boron's atomic number. That means that's 5 protons. 8 is oxygen. So every single oxygen, no matter where you find it in the whole universe, has 8 protons. That's what identifies oxygen. You know that atoms are made out of only 3 things: protons, neutrons, electrons. So everything that you know about everything that you see and that you are is made of only 3 things. It's just different combinations of these 3 things. So the atomic number is the one number that identifies what element it is.
So could there be an element with 130?
Okay, so the number of protons in an atom increases by 1, is the missing number there, increases by 1 as you move from left to right. Each atom has a unique atomic number. Carbon always has 6, oxygen always has 8, and the above symbol, this is a different book, but on the periodic chart I gave to you, I already pointed out where the atomic number is. Quiz time. What element has an atomic number 11? Sodium is correct. Very good. How about 29?
Copper.
Very good. Copper. How about 33?
Arsenic.
Arsenic is good. Every good scientist should have their periodic table in front of them. Good scientist, good scientist, good scientist. How about 2? Helium. Okay, very good.
The huge as well.
Oh, here's a new one, mass number. So you guys know what mass is, right? That's what's mass?
Protons,
Mostly protons and neutrons, because the electron is almost 2,000 times less massive than a proton or a neutron. It's 1,800 times less massive. So yeah, it's pretty much protons and neutrons. But we identified mass in the last chapter as the stuff that you're made of. And like if I said for Connor, if I squished all the space out of you, how much space would the leftover mass that makes up your whole body, how much volume of space would it take up?
Very little.
Couldn't even see it, right? Squish all of Century and everybody in here together, it might be like a speck of dust. Like a grape size is like trillions of tons, remember that? That's pretty massive. Okay, so mass number is protons plus neutrons. Okay. Example. If oxygen's atomic number is 8, that means it has how many protons? 8. And its mass number was 16, how many neutrons did it have?
8.
8. See how easy that is? The answer is 8. Very good. Hey, let's say if helium's mass number was 4, how many neutrons does it have? 2 is very right. Because helium's atomic number is 2, mass number is 4. That must mean that there's 2 neutrons. Any questions? Mass number equals protons plus neutrons. If the mass number is of phosphorus is 31, and I look at I look at the atomic number of phosphorus and I see the atomic number is 15, then the rest of that mass comes from the neutrons. Because a proton and a neutron have the same mass. How did I get 31? I just knew that. So that would be given for you. So that'd be 16 neutrons. Quiz time. If copper's mass number was 63, how many neutrons does copper have? Yes, 34 is the correct answer. Very good. Thank you very much for doing that simple addition. Okay. Isotope is a new name. Isotope. It's atoms of the same element with different numbers of neutrons. Could it have different numbers of protons? No, because if it has a different number of protons, it's a different element. So the only way I can have a different mass number of the same element is by having a different number of neutrons. Okay, so therefore, an isotope will have different mass numbers, but always the same protons, which is signified by the atomic number. Very good. Okay. Okay. Carbon-12, you heard of that one before?
Yeah.
6 protons, 6 neutrons. Carbon-14 is what decomposes.
Oh.
Have you heard of that one before?
Yeah. Yes.
Very unstable. You have carbon-6 protons and 8 neutrons. So this is the one that disintegrates. This is the one that over time changes. And so, like when things are alive, there's a certain percentage of carbon-14 that we're all made out of. And then there's a small percentage of carbon-12. Or there's another percentage of carbon-12 that we're made out of. When we die, or anything that's alive dies, then the carbon-14 start breaking down into carbon-12s. And they might go through 13s, I forgot about that, but eventually they end up with the carbon-12, and then they figure out, well, geez, there's a different percentage of carbon-12s than carbon-14s, and depending on that percentage difference, that's how they do what is called carbon dating. Okay, so we all have the same percentage of carbon-14s and 12s in us, as well as like plants and things. Living things all have pretty much the same percentage. And it all decomposes at the same rate. Oh look, boron 10 has 5 neutrons. What's its mass number? If it has 5 neutrons, or not its mass number, its atomic number. 5, right? Because its mass number is 10. 5 neutrons, you must have 5 protons. Okay, average atomic mass is what we were looking at. So we do have this on our periodic chart. The average atomic mass, we'll look at that here. So if you look at these numbers that we were referring to earlier, the top right on this. Now, one thing is, you're always going to want to look at this, the key. Right? You always want to look at the key on your periodic chart because you're not sure where the numbers are going to be placed on your periodic chart. So, let's look up here and some of the ones that we know. So, magnesium here, it says 24.305, and that's called the weighted average or the atomic weight on our periodic chart. And what that is all of the different types of magnesium that we have in the world. They put them all into something that they can mass them with, and then they divide that mass by the number of the particles that are in there, and they come up with this average weight per particle. But keep this in mind, there is not one magnesium that has an actual weight or mass of 24.3. Now, most likely, the most common isotope, so like magnesium might have 2 or 3 isotopes, but the most common isotope is usually what you would round to. So, like for this one, the most common isotope I would say is 24. But there's no actual atom that has 24.3 for its actual mass number. So that's the difference between the average. Like, for instance, like if I called on you and I said, hey, how much do you weigh? You could tell me an actual number, right? And I could say that for everybody, but if we wanted to figure out what the average weight of the whole class is, we'd have to put you all on a scale and divide by 25, and we'd give an average weight. That wouldn't be anybody's actual weight, would it? No, it'd be an average weight per person. Okay, so we talked about magnesium, we looked at the chart, and most likely, there are a couple that don't follow this trend, but most likely, the most common isotope for magnesium is going to have a mass number of 24. So what you do is you look at the atomic weight on your chart, and you round that to the closest whole number, and that should be the most common isotope. So let's see if you can do that here. I want you guys to jot this down in your books. What do you think, or in your notebooks, what do you think the most common isotope of these 4 symbols are, or these 4 elements? So look at your periodic chart, and I want you to try to figure that out. Okay, so here I'm going to show the answers and see how you did. Oh, I guess I'm not. I'm going to have to tell the answers. Okay, as a class we have decided 73, 75, 39, and 133 are the most common isotopes of those 4 types of atoms. Okay, very good. And one last little bit here for our notes today, and that's the number of electrons equals the number of protons in a neutral atom. And all atoms are neutral to start off. The only time they become something other than neutral is if they get electrons ripped away from them or added to them. So if I look on my chart and I see, oh, carbon has that number of 6, the atomic number of 6. That means it's 6 protons, but by default it also has how many electrons? 6 electrons, okay? And when I do an E with a little negative sign there, it's kind of the common symbol for electron, because an electron has a negative charge, proton has a positive charge. So let's look at fluorine. Fluorine has atomic number of 9. So how many electrons does it have? 9 electrons. Okay, do you have any questions about that? That's electrically neutral, because there's the same number of protons and electrons, they cancel each other out. Okay. And if we have something other than an electrically neutral atom, then we call it an ion. Okay? So an ion here is a charged atom. So let's just look at this. Let's say that I have carbon, or let's say I have fluorine, okay? And it's got an atomic number of 9, but let me say that it has 10 electrons. What does that mean? Is that an ion? Does it have the same number of protons and electrons? No, so that's an ion. Okay, so how many more electrons does it have? 1. So you would draw this symbol in ion form as a -1. So that means it has an electrical charge of -1. Okay? So let's look on the other side. Let's say that we have a sodium ion, and that has an atomic number, I'll start up here. Sodium has an atomic number of 11. But let's say that it only has 10 electrons. What does that mean for sodium as far as its charge? It's a +1, right? +1. So that's an ion too. Okay, do you know the name of these two ions? You better add this to your notes. Do you know the names of a negatively charged ion? It's called an ion. And this one is called cation ion. Okay? So the question is, a sodium atom ran into a fluorine atom. What did the fluorine atom say? You better watch it, I got my eye on you.